Have you ever been sitting in a physics class, or maybe you're just, deep in a Wikipedia hole at 2:00 a.m., and you get to the part about special relativity?
Oh, yeah.
The speed of light, time dilation, all that jazz. And they tell you that as you go faster, time slows down, and rulers, they physically shrink.
The standard curriculum. It's mind-bending stuff.
It is, but be honest.
Yeah.
Have you ever had that moment where you just stop and think, okay, that that sounds like cheating?
Cheating. That is a very specific accusation.
You know what I mean? Right. It feels like sophistry.
Yeah.
Like they're playing word games. It's like, oh, the math didn't work out the way we expected, so let's just say the ruler got shorter to make the numbers fit.
Right.
It feels like they're just debating you into submission instead of, actually explaining what's happening.
I think I know exactly the feeling you're talking about. It's that sensation that the explanation is just a mathematical patch over a gap in our understanding.
Yes, exactly. And the reason I'm so fired up about this today is because our deep dive is built entirely around that specific frustration.
It is.
We have a stack of dialogue logs today that are honestly unlike anything we've covered before.
They really are. Usually we look at articles or books. This is a raw intellectual throwdown.
It is.
It's a series of debates between a very skeptical, very sharp user who goes by the handle Chat and an advanced AI.
And this isn't just a tell me about Einstein chat. This user is like out for blood. They are using strict geometric logic to corner the AI and prove that modern physics is relying on fancy tricks on sophistry to explain the universe.
And here's the spoiler alert that makes this so juicy.
I want.
The AI actually cracks.
It does. It starts out defending the standard textbook answers, quoting Einstein and Lorentz.
And by the end?
By the end, it admits that the standard way we teach this stuff is lazy. It actually shifts its own probability assessment and admits the user has built a more honest model of the universe.
It's a fascinating journey. We go from, you just don't understand the math, to, wait a minute, you actually reinvented the theory from scratch using a better philosophical framework.
So buckle up. We are going to talk about rain, trains, invisible domes, and why your perception of now is essentially a gambling problem.
A gambling problem. I like that framing.
We'll get there. But first, to understand this battle, we have to start with the user's main weapon.
The analogy of the rain.
The rain. It seems so simple, but the user Chat just keeps coming back to it.
Right. This is the intuitive model. It's how our brains naturally understand motion. The user says, forget about light for a second.
Okay.
Let's just talk about physical stuff. Imagine you are standing in a field. It's a gray, miserable day, and rain is falling. But there's no wind. The rain is falling perfectly vertically, just straight down.
Okay. I'm picturing it, getting soaked.
Now, imagine you start running, really sprinting. Or, better yet, imagine you're sitting on a high-speed train looking out the window. What does that falling rain look like to you now?
It looks diagonal. It looks like it's slanting toward me.
Yeah.
If I'm running, I have to tilt my umbrella forward to block it.
Exactly. And this isn't an illusion. If you have a tube and you want the rain to go straight through it without hitting the sides while you're moving, you have to tilt the tube.
Right.
This is what we call the composition of velocities. You have the vertical speed of the rain mixed with your horizontal speed. The result is a diagonal path relative to you.
It's common sense.
It's Galilean relativity. It's how the physical world of matter works.
Okay, so the user says, fine, we all agree on the rain. Now let's look at light.
And this is the trap.
If the Earth is moving through space, which is like the train and light is coming from a star directly above us, which is the rain, then logically, that light should look diagonal to us, right?
And that is the logical assumption.
Yeah.
And it's not just the user's assumption. This is exactly what physicists in the 19th century thought.
Right.
They believed light traveled through a medium called the ether, just like sound travels through air.
So they thought they could measure the wind of this ether as Earth moved through it.
Precisely. They set up the famous Michelson-Morley experiment. They split a beam of light, sent it in two different directions, and brought it back together. They were looking for...
Just a diagonal shift.
Exactly. They were looking for interference fringes patterns that would show that the light traveling with the Earth's motion behaved differently.
And this is the part of history class where everyone gets confused.
Okay.
Because they didn't see it.
They found absolutely nothing. The light appeared to fall vertically regardless of how fast the Earth was moving. The interference fringes didn't move at all.
And this is where the user, Chat, basically starts screaming sophistry at the AI. Because how do physicists explain that? They don't say, oh, our logic about the rain and the train was wrong.
No, they don't.
They say, actually, the instrument you used to measure it is shrank.
Specifically, Lorentz contraction. The standard explanation is that the physical arm of the interferometer, the ruler itself, contracted in the direction of motion just enough to cancel out the time difference.
See, that's the part that feels like cheating. It feels like moving the goalposts. The user argues, you can't just shrink the ruler because you didn't get the result you wanted.
It feels like a cover-up to save the theory.
Right.
And you know what? The AI admits that this is a very fair critique of how the subject is taught. The user calls it circular logic. You start by assuming the speed of light is constant for everyone. And then, to make sure that assumption holds true, you invent a math rule that warps space and shrinks rulers. It feels like the math is bullying reality.
Right. It's like if I measured my living room and it was smaller than I thought, so I just declared that my tape measure got longer.
Exactly. The user is essentially accusing Einstein and his predecessors of fitting the facts to the theory rather than the other way around.
So is the user saying Einstein was wrong? Is this one of those, like, I found a flaw in physics conspiracy theories?
That's the twist. No, the user isn't saying the math is wrong. They aren't saying GPS doesn't work.
So what are they saying?
They are saying the philosophy behind the explanation is arrogant. The dialogue moves into this really deep debate about the grid versus the camera.
The grid versus the camera. I love this part of the logs. Let's unpack that. What is the grid?
The grid is how most of us and most textbooks imagine the universe. It's the God's eye view.
Okay.
Imagine a giant 3D graph paper that spans the entire cosmos. We assume there are clocks sitting at every intersection of that graph paper.
And we assume those clocks are all synchronized.
Right. We assume there is a universal now. If it's 12:00 p.m. here, we assume it is currently 12:00 p.m. on Mars and on Alpha Centauri, even if we can't see it yet.
We assume the universe has a state that exists independent of us looking at it.
That seems like a pretty safe assumption. I mean, things exist whether I look at them or not.
But the user stops the AI right there and says, wait a minute, that grid is a fantasy. It's a mental construct.
We don't have a God's eye view.
We are organisms. We are looking through a camera.
A camera.
A single point receiving information.
Yeah.
The user calls it the camera eye.
Okay, think about it. You are always at the center of your own universe. You aren't floating above the graph paper. You are down in it. And you only know what light hits your eyes.
Okay, I'm with you.
But light takes time to travel.
Right. 8 minutes from the sun. Years from the stars.
So you are never, ever seeing the grid. You are never seeing the universal now. You are seeing a sphere of information that is collapsing onto your retina.
No, I see where this is going. We are trapped in a bubble.
Exactly. The user introduces a geometric concept called the spherical cap, or dome.
A dome.
Instead of a flat grid of space that exists all at once, imagine a dome of incoming signals. Everything you see is plastered on the surface of this dome.
So the star I see isn't there right now.
The image of the star is hitting your dome right now, but the star itself is in the past.
So the user's saying, stop pretending you know what's happening everywhere at once. You only know what hit your camera lens just now.
Yes. And here is where the rain analogy gets flipped in a really brilliant way.
How so?
The user argues that vertical isn't a real thing in the universe. It's a calculation we make inside our heads.
Wait. If I drop a ball, it falls vertically. That's real.
To you, inside your frame of reference. But if I'm standing on the ground watching you zip by on that train and you drop the ball, I see it move in a diagonal arc.
It travels forward with the train while it falls.
Okay, sure.
So who is right? Is the path vertical or diagonal?
Well, relativity says both are valid.
Right. But the user says standard physics tries to force a universal vertical onto light. The user argues, the light is actually coming in diagonal because of our motion, just like the rain.
Yeah.
But because we are trapped in this dome of delayed information, we calculate it as vertical. We construct the map where it looks vertical.
So the weirdness of relativity, the shrinking rulers, the slowing time, that's not the universe doing magic tricks.
It's just a bookkeeping error.
Bookkeeping error is a fantastic way to put it. The expert term is epistemological. It's about how we know what we know. The user proves that standard textbooks skip the hard work of explaining how we measure things.
They just assume the answer.
They just assume the grid and then force the math to fit.
And this leads to the moment in the logs that really surprised me. The reverse GPS epiphany. This is when the AI starts to flip.
It is a pivotal moment. Up until this point, the AI is polite but skeptical. It rates the standard theory at 99% reliable. But after this argument,
The AI shifts to supporting the user's model at 85%.
85%, that's a massive swing for an AI trained on standard physics.
So what is the reverse GPS argument?
Okay, think about how GPS works on your phone. Does your phone inherently know where it is on the map?
No, it talks to satellites.
Right. It receives signals. Ping, ping, ping. Those signals have timestamps. Your phone knows the signal took, say, 0.06 seconds to get there. It assumes the speed of light is constant, and then it calculates its position based on that delay.
So the position isn't a measurement, it's a calculation based on the time delay.
Exactly. The user argues that the Michelson-Morley experiment, and essentially all of our reality, is reverse GPS.
So we don't measure the speed of light.
We assume the speed of light is constant, and we use that assumption to define where everything else is.
Whoa. Okay, let me try to restate that. We aren't discovering that light is constant. We are defining light as constant and then building our map of space to make that statement true.
That is exactly the user's point. And the AI loved this. It realized that the null result of the experiment, the fact that the fringes didn't move, wasn't a failure to detect motion.
It was the system recalibrating itself.
Yes, it's like if I decided that my stride is exactly 1 meter, no matter what. If I walk a distance that's actually 10.5 meters, but I take 10 steps.
You would just conclude the room is 10 meters long.
Yeah.
You warp the room to fit your ruler.
The user says we warp space and time to fit our assumption about light.
That makes the sophistry accusation makes so much more sense now. It feels like a trick because, in a way, we are tricking ourselves to create a stable map of the world.
But here's the fascinating part. The user doesn't just tear down Einstein and walk away.
Right.
They actually arrive at the same destination. This is the mathematical convergence section of the notes.
Right. The AI runs the numbers on this rebellious model.
It does. The user develops this model of the dome and something they call the M-axis.
The M-axis.
It stands for a measurement axis or a pseudo-time axis. It represents depth or delay.
So since everything we see is in the past,
distance is inextricably linked to time. The farther away something is, the further in the past it is.
And what did the AI find when it crunched the geometry of this dome and M-axis?
It found that it aligns perfectly with something called Minkowski space.
Minkowski space. That's the geometry of special relativity, right? That's the stuff Einstein used.
Yes. It is a complex 4D geometry that underpins all of modern physics. The user reinvented the geometry of relativity, but from a completely different starting point.
Einstein started with the grid.
Assuming coordinate systems exist. The user started with the signal, assuming only the camera eye exists.
And they ended up in the same place.
The same mathematical place. But the AI admits the user's path is more honest.
Honest how?
Because it doesn't rely on circular logic. It builds the universe from scratch using only received signals.
So it doesn't assume the grid.
It generates the grid. The AI explicitly says that the standard explanation relies on sophistry by assuming the grid exists.
There's a line in the text where the user accuses physicists of making light a slave. That stood out to me.
Making light a slave to the coordinate system. It is dramatic, but it's a powerful metaphor.
Right.
The user argues that in standard physics, we draw a graph and force the light beam to follow the grid lines. We say, light must go 45 degrees on this graph.
But light doesn't care about our graph paper.
Exactly. In reality, in the user's electromagnetic world, light moves how it wants through the field. We are the ones scrambling to draw lines that match it.
We are the ones adjusting our rulers and clocks to keep up with the light.
It's the difference between the map and the territory. Physicists love their maps. The user is obsessed with the territory.
And this leads to the deepest philosophical insight of the whole exchange.
The Pascal's wager of space?
Yeah, I know Pascal's wager as the religious argument. You bet on God existing because the cost of being wrong is, infinite punishment. But how does that apply to physics?
The user says space recognition is a bet.
A bet. Okay, break that down for me.
Think about it. Because of the speed of light limit, you never see the world as it is right now.
You only see where things were.
Right. If you see a baseball flying toward you, you aren't seeing it where it is. You see it where it was a fraction of a nanosecond ago.
Sure, for a baseball, that delay is so tiny it doesn't matter.
True. But for a planet, or a star, or an electron moving at near light speed,
it matters a lot.
The user argues that we are constantly betting on the location of objects. We take the old data, the ghost image, and we extrapolate. We say, it was there, moving that way, so I bet it is here now.
So our entire reality, our sense of space, is just a mental projection. A gamble.
Exactly. In Newton's world, the old physics, we thought we knew exactly where things were right now. It was a deterministic world.
We thought we were looking at a live feed.
But in the user's world,
In the real electromagnetic world, we are always interacting with ghosts. We're looking at a delayed broadcast.
we are chasing ghosts.
And because we can't know the true present, we have to construct a map.
And the bending of space and time and relativity isn't the physical world turning into rubber. It's our mental map, adjusting its odds to account for the delays.
That blows my mind. It makes relativity feel human.
Yes.
It's not about clocks flying through space. It's about us. It's about our limitation, about trying to make sense of a delayed signal.
It shifts the perspective from ontology, what actually out there, to epistemology, how we gather information. The AI was blown away by this. It admitted that by ignoring this betting aspect, standard physics ignores the fundamental uncertainty of existence.
And that's why the AI shifted its support, because the user showed that the grid is just a safe bet we all agreed to make.
Yes. The grid is a useful fiction, a collective hallucination that helps us agree on where the train station is. But it's not the fundamental reality.
The fundamental reality is the signal, the delay, and the camera.
This really changes how I think about that rain analogy we started with.
How so?
Well, the user wanted to say that light is like rain, it should look diagonal, but maybe the answer is, it is diagonal.
In a sense, yes.
Yeah.
In the absolute space of the signals, the path is diagonal. But our brain and our physics equations act like a corrective lens.
We run the reverse GPS calculation instantly and say, nope, it's vertical.
We edit the footage in real time.
We are living in post-production.
Yeah. That is a fantastic way to put it. We are living in post-production. We never see the live feed.
We take the raw footage from the past, we apply our grid filter, color correct the speed of light, and present it to our consciousness as the present.
That is slightly terrifying, but also really cool.
It connects to quantum mechanics too, which the user touches on at the end of the logs.
Oh.
If position is just a bet based on delayed info, then you can't be 100% sure where anything is, you only have a probability.
So this sophistry debate actually opens the door to quantum theory.
It suggests that the uncertainty of quantum mechanics isn't just about tiny particles being weird. It's about the fact that any observer in a universe with a speed limit is forced to gamble on the state of reality.
You can never be certain.
You can only have good odds.
It's logical consistency all the way down.
It really is. It unifies the big weird stuff, relativity, with the small weird stuff, quantum mechanics, just by taking the observer seriously.
So let's wrap this up. We started with a frustrated user yelling at an AI about rain and trains. We moved to domes, camera eyes, and reverse GPS. And we ended up realizing that space is basically a map we draw based on delayed text messages from the universe.
And the takeaway isn't that Einstein was wrong. His math works. Your GPS works. But the story we tell about why it works, that needs an update.
The AI admitted as much. It said the standard teaching is lazy because it ignores the camera eye.
It ignores the struggle of the observer. It hands you the answer key, the grid, without letting you take the test, the observation.
I love that. It validates that feeling of cheating I mentioned at the start. If you feel like physics is cheating, it's because they skipped the part where they explain how the game is played.
Exactly. They showed you the magic trick but didn't tell you about the mirror.
The user found the mirror.
And once you see the mirror, the delay, the dome, the trick isn't magic anymore. It's just geometry.
So here's a provocative thought to leave you with.
Yeah.
If everything we see is a bet based on old information, if we are always living in post-production, did we ever actually experience the present?
That is the big question, isn't it?
Are we strictly living in a reconstruction of the past? And if so, how big is the delay? Is it nanoseconds? Or is our entire consciousness just a memory of something that just happened?
If you think about it, by the time your brain processes the electrical signal from your eye and builds that grid in your mind, that moment is already gone.
We are all time travelers.
Yes.
Stuck just a tiny bit in the past.
Navigating by map, hoping the territory hasn't changed too much since we last checked.
I'm going to go stare at a wall and question my reality now. Thanks for listening to this deep dive. Question the grids in your own thinking, everyone.
See you next time.